The sound of a car starting is like music to the ears when it's minus 15 outside. Today's batteries are increasingly powerful and efficient, even at the most extreme temperatures. Kind of heartwarming, isn't it? While dissecting a frog in 1786, the Italian researcher, Galvani, noted that when his scalpel touched a leg muscle, it contracted from an electric current produced. Later, Volta believed the current was produced by the metal instruments, the animal being only a conductor. To prove it, he stacked discs of zinc and copper, connected by conductors, and fabric impregnated with an acid solution. And so, in 1800, the electric battery was born. Batteries power all kinds of electric motors. A new lithium metal polymer battery pack such as this one could soon power an electric automobile as well as a hybrid vehicle. This battery will be made up of 4 components. It all starts with this lithium ingot, which weighs about 5 kilos. It's transformed into a thin sheet by this extrusion press that applies 400 tons of pressure. From it will exit a sheet that's only about 250 microns thick. The whole extrusion sequence is closely computer controlled. Extrusion is now completed. The metallic lithium sheet is the required 250 microns in thickness, or a quarter of a millimeter. The sheet has to be further thinned. Placed on a roller, it is carried to the laminator. At room temperature, it's thinned once again. In just 20 minutes, the 5-kilo ingot will have been transformed into a thin, 250 micron sheet, some 200 meters in length. This laminator completes the thinning of the sheet to between 20 and 40 microns. The resulting 2-kilometer-long sheet will allow for the fabrication of 210 battery units. Lithium is a soft, sticky metal. For this reason, a polypropylene film has to be fixed on the lithium sheet. Without this protection, the sheet would adhere to itself and become unusable. The sheet will be used to make individual battery cells. Then these cells will be assembled in series and in parallel and inserted into modules of different shapes. To make an individual battery cell, the sheet has to be rolled up. This automated spooling machine winds up the lithium film in 26 revolutions. The wound-up sheet is put into a vacuum oven where the various layers adhere firmly to one another. This step lasts for about 90 minutes at 80 degrees centigrade. Here, a test is made. Using a voltmeter, the battery is checked to see that it produces the required 3.56 volts. Any problem can be detected here and corrected. A final quality check is made with this caliper, which precisely measures the thickness of the battery cell. The battery cells are then stored. Metallic plates are placed between them for the entire storage period. One more step remains, and that's the metallizing of the contacts. The battery cells are sent off to a fabrication facility in this container. The container is robotically handled. First, it's put into a protective tank. Then the metallizing of the contacts is done by spraying on molten metal. This takes just a few seconds, since the metal cools very quickly. The battery is now finished. It comprises 4 elements: lithium, which acts as the anode, a metallic oxide cathode, a dry solid polymer electrolyte, and a metallic current collector. All that remains to be done is the assembling of the individual battery cells into a module. It begins with the placing of individual cells onto one another and isolating them with foam so that they don't touch each other. These red sheets are actually heating elements since the lithium metal polymer cells function at temperatures of between 40 and 80 degrees centigrade. All of the individual battery cells of the completed module are connected to an electronic card located above the module. The finished modules are connected to one another in series and in parallel to form a battery pack, which can be used in an electric automobile or a hybrid vehicle. Here we see these modules of a battery pack for a hybrid vehicle, an automobile that works with a gasoline-powered motor and an electric motor. This prototype battery was created for a totally electric vehicle. It surpasses heavy traditional lead-acid batteries that can't develop the same amount of electrical energy and which have much shorter lifespans.